Frank, this is an unusual setting. A mill run by what? Steam?
It is run by steam. It wasn't originally run by steam. In the earliest days it was run by water, which is the water wheel. In the Victorian period they decided they were going to put a steam engine in. High technology in its day.
And this would be about
1850, around about that sort of period. They put the steam engine in and they basically used it to drive saw machinery, which was in the building that just behind us as we're talking at the moment. The water wheel could either drive the sawmills or the steam engine could drive it.
There was a water mill here which was mentioned in the Domesday Book, and at that time the village of Coombe was down here, and then when the Black Death came they decided that being near the river, the miasma, was not a good thing, and Coombe moved up to the top. I guess at that time it was probably a flour mill, but we don't know. And then when the Blenheim Estate came,
1700 plus.
yeah, the mill probably was here at that time. And in those days, the old maps show that all this yard out here was mill pond, and what we now see as the river was a marshy sort of bypass. In the early days, there was a weir here somewhere, and all this was mill pond, all the way down there.
I.e. storage of water,
Yeah.
which you could draw on to drive the
and
wheel.
anything that you didn't want came back through a bypass here. And what we would like to do is to get a weir in here so that we can get the water that way. At some date, which I can't tell you, the water wheel was changed from an ordinary undershot to an improved undershot.
So that means the water went underneath the wheel,
Yes.
not over the top.
That's right. And with flat paddles that just got pushed round. Now, with this one, you can see instead of flat panels, we've got buckets. And where the wheel runs round in an arc, so underneath the bed of the stream runs round in an arc. So there is no great gap between that and the wheel. We get more power for the same amount of water. It's on this spindle, this axle, which is a tree trunk, best part of 2 foot, I would think. And then in each end there's a cross slot cut, and the metalwork is jammed in to give us the bearing at the end.
The bearing is metal.
The bearing is metal, and wedges are put in to get it centred. And the same thing happens at the other end. And the other end, or the other side of that wall, is what's called the pit wheel. The pit wheel on the same shaft, it does 1 revolution for 1 revolution of this wheel. That pit wheel has wooden teeth. The one above it, which is smaller, is a cast iron wheel. So that goes faster by the ratio of diameters. There is a wheel which is not in place at the moment, which would connect that wheel to the line shafting. So the idea was you could slide that little one across to engage with the wheel or release it. So that if you were using the water wheel, you could slide it into mesh, and if you decide to use a steam engine, you could slide it back off again. All the way through, there's alternately wooden wheels and cast iron wheels, and there seem to be several reasons for that. One is that should anything seize in the system, then you'll break a wooden wheel rather than a cast iron one, because the wooden teeth are individual and can be replaced.
Made of?
In here they're made of hornbeam.
That's the usual one in mills, isn't it?
Hornbeam, we're not told now, is all right if it's always dry, but it should be oak if it's sometimes wet. So perhaps we should have used oak, but we didn't know that until we'd made the hornbeam ones.
What about the danger of fire?
Well, the thing about, another reason possibly, is that if you have metal to metal, you might get sparks. Now, in a flour mill, with the dust around, it can be an explosive mixture. And there have been instances where there have been explosions from flour dust. In fact, almost any dust can cause an explosion. So that's possibly another reason why. And The third possible reason is that if you have metal to metal, you probably need to grease them. If you put grease on there, you get dust and grit, and so instead of a grease, you've got an abrasive mixture. And with metal to timber, you don't need anything. So I think between them, those three possibilities, one of them must be the right answer.
This obviously is not the original mill wheel.
No.
When would this one have been made? It looks Victorian for some reason.
We think it's about that sort of time. All we do know for sure that this one was put out of use about 1960. So that's when they completely filled in the mill pond.
So one of your objectives must be to make this operational again.
Yes. But
How far away are you?
A double objective. First of all, we have got to get permission from Environment Agency to raise the level of the river a bit. And what we would like to do is to put a small weir in out here. And we would like to raise the level of the river by about half a metre.
And how would you do that?
Well, if we put the weir in, right, and open up what used to be the bypass, the river will come in there.
Bringing it back to its original intention?
Yeah, that's right.
So how far off is that?
We have now found an expert on water mills, and we are waiting for a visit from him. He's also been very much involved with the Environment Agency, and so we have asked him to sort of broker the deal between us. They were going to get back to us, and we've not heard a thing from them. But certainly in the Domesday they didn't have to have a license to extract water.
But when the water wasn't sufficient in the Victorian period, they decided they were going to put a steam engine in.
Did you have to do much restoration?
It hadn't run for 55, 60 years. It was quite a long time. Actually, surprisingly, to get it going in the first instance, from what I'm told, not much. They managed to steam it very well, very quickly. But then, of course, they steamed it in its original rusty state, but then it was restored. It's never been restored, if you like, to a pristine condition. It's never been looked like Q or any of these other wonderful steam engines. It's always been clean and tidy, shall we say. The old Cornish boiler, which was installed at the same time as the steam engine in about 1860, it used to take us nearly a week to get it steamed up. I mean, basically, if we were steaming on a Sunday, the guys would first light the boiler on a Wednesday. They'd light it on a Wednesday, let it cool down again, light it again on Thursday, and then on Saturday they'd light it to get up steam, and then finally relight it again. And this was all to allow the thing to gently warm up and reduce the expansion and contraction and all of the other things. So it took a long time, and an awful lot of wood, because we used to use the wood that was on the wood yard. So it was quite an effort. We really found it quite difficult to steam more than 4 times a year. The old Cornish boiler was really about as simple a boiler as you could ever get. It doesn't have steam tubes or anything else. It only has a basic fire tube with 2 cross tubes that go through it, and that's it. So it's as near as you get to a kettle that you would expect. It's a riveted boiler made of wrought iron, reasonably efficient, but not that efficient. And then, of course, we had the tragedy when the thing rusted through. We're going back now 3 years now. But that was the thing that revolutionised what happened to the mill, in the sense that we had a major rust through. Blenheim Estate decided they were going to develop the estate. It looked like Combe Mill was going to close. Eventually didn't, after a lot of hard work by a number of people. Because the boiler had rusted through, we had to install a modern oil-fired boiler. The joy of that is it only takes 2 hours to steam. Therefore, we can steam it literally in the drop of a hat. So now we can steam basically every 3rd Sunday of the month from March through to October. And the amount of effort required is considerably less.
Can you tell me a bit about this machine? It's a beam engine, isn't it? There's a huge beam which is, say,
17-foot beam, 17-foot flywheel.
and it goes up and down in one cylinder.
One cylinder, double acting, and it's condensing. And the condenser is sitting in cold water, which is pumped up from the river, and then overflows back down to the river.
And at the business end, you've got a crank, which starts to transfer the power throughout the building.
It does. It takes it from the crank onto the flywheel. There's a shaft through the wall there, a large drum on the other side, taking it up onto line shafting. The line shafting goes all the way through the building. But apparently, at the turn of the century, there was over 70 people working here, because this was a pattern-making workshop as well as the powerhouse.
In its day, it must have been fairly high-tech.
Fantastically high-tech, because in 1852, it was only just after Bolton and Watt had decided that it was a good idea to sell blueprints rather than engines. Because
They didn't have the bother of
well,
making
they
it.
didn't have to transport it. You know? So that's what we assumed happened.
Where was this made?
We don't know. There are no names on it. There is no indication as to where it came from. We do know that the faceplate of the boiler has the name Pickett written on it. We also know that that little handle down there on the valve has got Pickett written on there. But I think they made the handle and the faceplate of the boiler. Everything else appears to have been very much locally made. And I think the whole castings were probably all done locally.
There's a huge flywheel.
It's a fair size.
Was it 30 feet across?
Yes, and it's not in one piece. It is bolted together. So it is in two sections under each one of
Isn't that dangerous? Might it not break and fly apart?
Well, we've never had any indication that it's likely to do that sort of during the time I've been here.
A lot
anyway.
easier to make if you make it in sections.
No, and yet, in fact, if you look at it, if you look at the periphery of it, it's going round, you'll see that it does tend to rise and fall in one or two places.
Yeah, I'd rather not watch that.
Well, it does. But you see, they overcome that problem by having cast teeth on the flywheel, but the cog that it's driving down there has wooden teeth. So as long as you keep the wooden teeth, that gives you a certain amount of play and movement to be able to take up any imperfections that you've got on the gearbox. So they've got it all well sussed out. This has always been, if you like, the sort of the workplace for the Blenheim Estate. It was also used commercially. I mean, a lot of what they did was commercial, but also it was in support of everything that the estate did. I mean, Blenheim Estate is 20,500 odd acres. It's a huge estate. It's fairly high in agriculture, and apart from the park area, therefore they needed a lot of support. They needed a lot of wood to make gates and fences and all of the things, and most of the stuff was done here. Most of the heavy engineering in terms of ironwork and everything else, that's what the forges were for. But it also was commercial, because upstairs in the old mill, they used to, amongst other things, make patterns for cast iron machinery and cast iron gear, tools, anything that could be made in cast iron. They used to make the high quality patterns. If you go upstairs, you can actually still see some of the patterns and the cast material. It's quite interesting to balance a wooden cast gear, which probably weighs about 2 pounds, and the actual cast gear, which weighs about 20 pounds. In the Victorian era, power was always transferred by line shafting and belts, sometimes gearing, but primarily line shafting and belts. The line shafting in here did three things. You could decide which power source you're going to have. So via the line shafting, the water wheel could either drive the sawmills, or by the line shafting, the steam engine could drive it. And also, because of the belting system, it went upstairs to what in those days was quite high-tech machinery, bandsaws, lathes and all of that sort of thing, which the precision woodworkers used upstairs as well. So it was just a means of transmitting the energy around. Nowadays, every machine's driven by normally an electric motor from an electricity grid. Well, in those days, everything was driven from the line shafting via a belt.
In the machine shop on the ground floor, all is bustle and noise. 3 small freestanding steam engines fussing away self-importantly, and a restored small corn mill driven by the beam engine working away with a little less haste and a lot more dignity. The whetstone used for sharpening tools would normally have been operating, but it was waiting for a new leather belt to connect it with the line shafting. In the machine shop on the first floor, more noise and bustle. Several of the 19th century crafts on display have no direct connection with the interests of the Blenheim Estate, but their engineering artefacts are well represented. It's a barn-like building, isn't it? Say 150 feet long, with an open roof and beams across, a foot square, and lots of things hanging down from the roof. Bits of machinery. There's a huge wooden rake over there. What did they do here? What is a pattern?
Well, the term a pattern-making workshop is where they made wooden patterns for the casting of materials. For example, drain covers, which were made of cast iron, were first made in wood. Secondly, gears were first made in wood and cast into iron, and so they were making the patterns to develop the various things that were needed. And as you can see, the one that's in front of us here is about 18 inches in diameter. It has got 6 spokes in it, and it is indeed a sprocket or a gear wheel. That gear wheel would have been taken to the Cowley Ironworks, and it would have been cast in sand, and they would have produced a wheel exactly like that. But you will see here all sorts of other patterns. Bearing housings, yeah. A lid for a drain, where that would simply drop in. Another piece in cast iron, which is a top for a drain. There's a set of examples here. They are shapes that were used, templates that were used to shape the felloes of a wheel. Now, the fellows of a wheel, there's usually 6 or 7 of these to make up the circumference of the wheel.
So that's the outer edge.
Yes, the outer edge. Just behind me here is a bandsaw, and the bandsaw was used to cut the felloes out. And therefore you've got it set up and run, and somebody would be here all day cutting out these fellows. But in association with that is this very large lathe that's over here for turning the hubs for cartwheels. And these hubs would be something in the order of about 12 to 15 inches in diameter, and they would probably be about 12 or 15 inches long. But on this lathe here, they were turned up and then left in the water for 12 months before they were used.
To expand?
Purely to let them regularize themselves. They were invariably turned out of elm, and elm is a wood that's got a tremendous grain in it. And besides curing the wood, you've got to let it settle down after you've turned it. And this was the purpose of it. Turning it, putting it into water, letting it soak, bringing it out, letting it dry, and then you could use it. Probably 2 or 3 years.
Nothing like the Japanese just-in-time method, is it?
Or just too late.
The bandsaw was standing idle, waiting for a refurbishment. But there's always the lathe, 160 years on, still driven by the Victorian line shafting. So there's plenty to see.
There's lots to see. And
what would you pick out for me?
Depends who you are. I think if you're an adult, I think at the end of the day, still the steam engine is the joy to see. I think from the children's point of view, there are lots of small engines that they can look at and touch. But most of the pleasure that children get is from either making a poker, the opportunity to actually get on a real blacksmith forge and heat and beat red hot steel into a poker, or to go upstairs and use a lathe and turn the handle for your poker. So it's really quite a lot for the children to do. Health and safety has made it very much more difficult for us to do it, but we do it safely with gloves and masks and everything else. So at the end of the day, it's quite a safe procedure for the children.
Not burn the handle.
Let it go then. Yeah.
Oh.
Keep going. Before it gets too cold, 'cause it goes cold really quick. That's it, well done.
Dad, is that side more?
Yeah.
The line's more sharp.
Yours is more pointed, you're right. You're quite right. Yep, spot on. Right, you can do the twist next. Can't you?
I don't use my hammer for it.
Yeah. So it's harder work than playing on a PlayStation, isn't it?